All right, let's finish out the notes from today. So this next example just asks us to graph the ellipse with this equation. So remember, to get the information that we need out of the equation, we need it to be in standard form, which means I need a 1 right here. So I just need to take this and divide every term by 16. So when I do that, 4 over 16 would reduce to 1/4 plus, we would just have y squared over 16 equals 1. So now, my center of this ellipse is going to be at 0, 0. The square root of this value tells me how far to go to the left and to the right of the center. So the square root of 4 is 2. So I'm going left 2 and right 2. Then the square root of this value tells me how far to go in the y direction. So the square root of 16 is 4. So up 1, 2, 3, 4, and down 4. So my ellipse will look something that's not real good, but that's our ellipse. All right? So the next one gives us an equation with a center not at 0, 0. Okay, and then we need to get all of this information out of our equation and graph it. So the center, okay, we said that our standard form was x minus h squared over a squared plus y minus k squared over b squared equals 1, right, where hk is the center. So here, the center will be at 3, negative 1. Right? Just like circles and parabolas, it's always x minus h and y minus k, so we need to take the opposite sign when we're determining the center, or in the case of a parabola, the vertex. So my center is going to be 3, negative 1, and I actually, did not make my graph big enough, so I'm just going to scoot this axis over a little bit and replot my point. So at 3, negative 1. Now, the square root of this value tells me how far to go left and right from the center. So the square root of 25 is 5. So from the center, I'm going to go right 1, 2, 3, 4, 5, and left 1, 2, 3, 4, 5. Okay, so those will be the endpoints of the major axis, which we call the vertices. So those coordinate points are negative 2, negative 1, and what are we at? 3, 4, 5, 6, 7, 8, negative 1. Now I know that those are going to be the major axis because this is a larger number than this, right? So my x distance is going to be larger than my y distance. Okay, so now this tells me how far to go up and down, the square root of this number. So up 1, 2, 3, and down 1, 2, 3. Right, so those coordinate points, the endpoints of the minor axis, are at 3, 2, and 3, negative 4. Okay, so we can sketch out the ellipse. Not the best. All right, so then the last thing we need are the foci. Okay, so we know that the foci are going to be somewhere on the major axis. To get those, remember, we use this a squared minus b squared equals c squared, or it could be b squared minus a squared, right? We're just taking the larger of these values minus the smaller one. So here we would say 25 minus 9 equals c squared. So we get 16 equals c squared. Take the square root, and we get that 4 is equal to c. So remember, this is the distance from the center to the foci. So I'm going to go 1, 2, 3, 4, and 1, 2, 3, 4. Okay, those will be where my foci are. So the foci are at -1, -1, and 7, -1. All right. Let's try the next one here. So this one says find an equation of an ellipse that has foci at -3, 2, and 5, 2, and a major axis length of 10. Right? And sketch it. So I'm going to start with the picture here. All right, so I've got my foci at -3, 2, and 2, 3, 4, 5, 2. Okay, so I know a couple of things just from that. First of all, the vertex is going to be exactly halfway in between the foci. So the distance between these two foci is 8, right? So that means that if I go a distance of 1, 2, 3, 4, that'll get me to my vertex. Okay, so if we're thinking in terms of this equation, okay, one of the big pieces of information that I need is, I called it the vertex, didn't I? Sorry, that's not the vertex, that is the center. Right, so we've got the center and the foci. So one of the big pieces of information I need is the center, which is at HK. So right off the bat, I can say, well, my center is at the point 1, 2. So I can fill this in. This is going to be x minus 1 squared over something plus y minus 2 squared over something. And it's going to have to equal 1. Well, now, if we know the major axis has a length of 10, right now the distance between the two foci is 8. So if the endpoints will just be one more in either direction. And the endpoints of the major axis are the vertices. So the distance from the center to one of the vertices in the x-axis, right, is a distance of 1, 2, 3, 4, 5. So 5 squared is what I'm going to put underneath of my x over here. So that'll be 25. Now, we still need to get this value. Okay, and to do that, I'll do it up here. We're using our, I'll do it down here. We're using our a squared minus b squared equals c squared idea. So here we have the distance from the center to a vertex is 5. So 5 squared. And then we want to solve for b. Then c is the distance from the center to a focus. So that distance is 4. So 4 squared. So we've got 25 minus b squared equals 16. Subtract the 25 over. Divide by -1. And take the square root. And we're going to get b equals 3. Okay. So b squared is equal to 9. So here is my equation. And then the last piece of information I need to graph it was this. Okay, the square root of 9, which is 3, tells me how far up and how far down to go in the y direction. So I ellipse. Yeah. It's going to do something like that. That looks more like a potato. All right. So our last example then is taking an equation in general form and rewriting it so that it is in standard form. So we are going to have to complete the square twice on this one. Right? So to set this up, we want to collect the x's together. So I'm going to just kind of rewrite this as 3x squared plus 12x plus, I know I'm going to have to add something, and then I'm going to collect the y's over here. So 4y squared minus 8y plus something to complete the square. And then I'm going to go ahead and add the constant over to the other side. So if I add 32 over, we'll have positive 32 over here. And then I know I'm going to have to add 2 things to this side because I'm adding 2 things to this side. Now, if you remember, when we complete the square, we need to have the leading coefficient of our squared term be 1. So what I can do on both of these is factor out the leading coefficient. So here, if I factor a 3 out, I'd be left with x squared plus 4x inside of my parentheses here. And then I can factor a 4 out here, and I would be left with y squared minus 2y on the inside here. So now we need to complete the square. Half of 4 is 2, and 2 squared is 4. So I'm going to add 4 right here. But here's where we need to be careful. I'm not going to add 4 to this side. I'm going to add 3 times 4, which is 12. All right? So be careful that you don't just automatically put this number here. We're actually adding 3 times 4 to the left side of the equation, so I need to do the same thing over here. 3 times 4. Same thing here. Take half of negative 2 is negative 1. Square it, we would get positive 1. But I'm not adding 1 to this side, I'm adding 4 times 1. So 4 times 1 is 4. So now what we have is 3 times, this will factor into a binomial squared, right? So this, remember, is just x then half of b, so this would be x plus 2 squared. Then here we'll have plus 4 times, now this factors into y minus 1 squared. Remember, half of b is the value that goes right here. Equals 32 plus 12 plus 4 is 48. Now I want this to be a 1, so I need to divide everything by 48. 48, and then we just simplify the fraction. So 3 over 48 would be 1 over 16. Then 4 over 48 would be 1 over 12, and equals 1. Okay, so this would be the standard form of this equation. All right, we will do the homework together in class tomorrow.